question number 3 on section 2.3 is giving a couple of you fits. I've had 1 or 2 questions today about this specific problem, and I've sent out a couple of hints on how to go about solving that. I don't know if those of you that have asked about it have been able to solve it, because I've not heard back from anybody since, but I decided to just go ahead and give you all a couple, well, actually not really just give you hints, but kind of walk you through this problem to make it a little bit more simpler. So the things that we need to first make note of is this question does have, or this test that we're talking about has 10 questions. Each question has 4 possible answers, but however, this is still what we would consider a Bernoulli trial because there's only 2 possible outcomes. They get the question correct or they get the question incorrect. So the probability of success would be if they get the question correct. So they have a 1 in 4 chance of getting any one of those questions right. So that means our probability of success is 0.25, which gives us a probability of failure per question of 0.75. And that's really all you need to get started on this question. So for part A, and that's where some of you are reaching your first stumbling block, part A says what's the probability that they get at least 1 question correct? And I have seen several solutions where you've calculated correctly the probability that they get exactly 1 question correct. But keep in mind, at least 1 means that they can get 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 questions right. That's the probability of at least 1. So we would have to add all 10 of those probabilities together. But there is an easier way to do this. I'm first going to make some algebraic notations, and then maybe this will make more sense to you. The total probability for all 10 questions should add up to 1. If we take the probability for every single question and add them together, we should get 1. Because all of our probabilities are going to be between 0 and 1. The sum of any event of the probabilities should add up to 1. So what we're looking at in that case is the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 2 plus, and we can continue that on all the way out to the probability that x equals 10. We know that should all add up to 1. Part A, what we're interested in is the probability that x equals 1 all the way out to the probability that x equals 10. So there is one term that we are not utilizing in this problem, the probability that x equals 0. So I can use just algebra to rewrite the line that I currently have on the screen there as a simpler form. Rather than computing the 10 probabilities for x is 1, x is 2, 3, 4, 5, all the way out to 10, and then adding those together, I can actually do this by computing one single probability, and then we're done. What I can do with this equation that's written on the screen right now is I can subtract the probability that x equals 0 from both sides of the equation. And what that leaves me with is the probability that x equals 1 plus the probability that x equals 2 all the way out to the probability that x equals 10 is equal to 1 minus the probability that x equals 0. This is much easier to solve than computing 10 probabilities and adding them together. If you've already done this problem and you computed 10 probabilities and added them together, that's fine. Your answer will be exactly the same as if you do the technique that I'm about to show you right now. So all we need to do is compute the value for this right-hand side of the equation, and it will tell me the exact probability of x equals 1 through x equals 10. I will get all the sums because this is an equation. This left-hand side, the probability of x equals 1 plus the probability of x equals 2, all the way down through the probability of x equals 10, is equal to 1 minus the probability that x equals 0. So the probability that x equals 0 is very simple to compute using the probability formula. We would get 10 choose 0. Probability of success is 0.25 raised to the 0 power times the probability of failure, which is 0.75 raised to the 10th power. And when we type that in on our calculator, this ends up being equal to 0.056314. So all I need to do now is subtract that value from 1, and I get a probability of 0.943686. So what we're looking at for part A is there's a 94.4% chance that this individual will get at least one question right simply by guessing, given that they have 4 possible answers to choose from per question. For part B, what's the probability that they pass the exam? So the probability that they pass the exam is found given that a passing grade is 60%. Now this question, don't get confused, the question just asks for a passing grade. It does not say that they get at least a passing grade. So we are looking for the probability that x is equal to 6 because they have to get 6 questions right in order to receive a passing grade. So this is going to be 10 choose 6 times 0.25 to the 6th power times 0.75, and this is going to be, the power on this is 10 minus 6, so it's going to be 4. We type this in our calculator, and we get 210 times 0.000244 times 0.316406. So we multiply all those together, we get 0.01622, which means there is a 1.6% chance approximately that this individual will receive a passing grade if they guess on every single question. That this means that they're 1.6% chance that they'll get at least a 6, or that they will get a 60% on the test. Part C looks at the probability that they will get a 90 or better. So this means we have to include 2 probabilities. The probability that they get 9 correct, that's 90%, plus the probability that they get 10 correct, which would be 100%. So we're going to do the probability formula twice and add these together. So we have 10 choose 9 times 0.25 to the 9th power times 0.75 to the 1st plus 10 choose 10 times 0.25 to the 10th power times 0.75 to the 0 power. And when we compute this and add them together, we get 0.0000296. So that is a very small probability that this student, simply by guessing, will receive a grade of 90% or better. I believe we already did parts D and E. The mean, remember, the mean is going to be, for part D, that's actually what we're finding, is how many questions would you expect the student to get correct. That's simply the mean And we use the formula mu is equal to n times p. So in the context of our problem, n is 10. P, which is the probability of success, is 0.25. Multiply those together, and you get 2.5 questions correct. And then the last thing, which is part E, is asking you to find the standard deviation of the questions. And the standard deviation formula is the square root of np times 1 minus p. Make sure that I've written that down correctly. I'm pretty sure I did. And when we compute that, we already know what np is. We calculated that because np is simply the mean. So we get 2.5 times 1 minus the probability of success. And we're going to take the square root of that after we simplify everything. So it's 2.5 times 0.75. Take the square root, and we get 1.37 approximately. So I had to do rounding. So the standard deviation is approximately 1.37. So that is question number 3. I hope that this is of benefit to those of you who are struggling with it, and that this does make sense. Please ask questions. You guys absolutely are not bothering me. I'm glad that you're asking questions, and I will continue to answer as many of them as I can.